Okay, so little bit on Cornell notes here. It's a pretty easy way to get you guys uh, to get into the material and look back at it and actually study from it. So this is the text we're using here, and this section is 4.2. I put the objective in here. This is what you're supposed to get out of it. You can calculate speed of an object by dividing the distance covered by the time. And then on your left column here on Cornell Notes, it's always like divided into two columns. On the left, you put the question, the main idea. This would be a good place for the topic to go. And then the details go in here on the right. So I've scaffolded in for you. I've given you what I want you to know in these three main ideas. So you can sort of focus your note taking on that. And then at the end, I'd like you to summarize what you read. So we can go over here as an example and look at this section 4.2 speed. It says before the time of Galileo, people described moving things as simply slow or fast. Such descriptions were vague. Galileo's credited as being the first to measure speed by considering the distance covered and the time it takes. So speed is how fast an object is moving. And you can calculate the speed of an object by dividing the distance and the time. So here's an example. We've got a cheetah. If the cheetah goes a distance of 50 meters in a time of 2 seconds, then its speed was 25 meters per second. So 50 divided by 2. Fun fact, cheetah is the fastest land animal. It does cover distances over 500 meters. It can achieve peak speeds of 100 kilometers per hour. That's pretty crazy. Pretty fast animal, and it has to be to catch its prey. Any combination of units for distance and time that are useful and convenient are legitimate. So any units are okay. Miles per hour, kilometers per hour, centimeters per day, light years per century. But what we want to do in the SI units, we're going to be using meters per second for speed. And here's a little comparison. We mentioned the cheetah. Cheetahs should be on here. Yeah. Cheetah, when it's sprinting, can go 28 meters per second. Compared to, like, say, if you're a softball player and you hit the softball, your softball could be going 33 meters per second. If you're a bowler, you could be bowling at something like 6 meters per second. So how does this translate to our notes? How speed is how fast an object is moving. So then I would put my notes in here. You can make a note about Galileo, calculated. You don't have to have nice handwriting like me. Distance over time. You could write about the SI units, our meters per second, and like some of the things I highlighted would be a good thing to put in my notes on the details, okay? I'm going to look at my next page because we talk about instantaneous speed and average speed. Now, notice in the text, this is its own heading, and so is this. So it's an easy way in a nonfiction text or science text to use that as your main topic, main idea, or main question. They always seem to divide them up into headings and subheadings in these types of books. So talking about instantaneous speed, I'm going to get my trusty highlighter out again. It says the car doesn't always move at the same speed. Very true. Car may travel down the street at 50 kilometers per hour. Slow to 0 kilometers per hour at a red light. Speed up to only 30 kilometers per hour because of traffic. So you could tell the speed of a car at any instant by looking at the car's speedometer. I'm going to underline that one because I felt like that was important, that you look at the speedometer. And also in these nonfiction texts, when you have graphics and captions, that's usually a sign that it relates, as an example, to the main idea too. So here we have the odometer underneath here that tells you the distance, and the speedometer tells you how fast you're going. So the speed at any instant is instantaneous speed. All right. If you're going 50 kilometers per hour for only a minute, and the car continued at that speed for a full hour, it would cover 50 kilometers. If it continued at speed for only half an hour, it would only cover 25 kilometers. If it was only doing that in 1 minute, the car would cover less than a kilometer. So instantaneous speed is like when you're looking down at the speedometer. It's um, at any given instant. You could have your car speed go up and down like text acknowledges, and hey, and I'll show you how we would find that on a graph by just taking the tangent of a line. So if I said, oh, at this time, if this was 1 hour, I would say find the tangent to the curve at that point, and that would be the instantaneous speed. We'll get into that more when we do graphing. Right now, just know the instantaneous speed is something we could find with our speedometer. Okay, so in my note taking, I think it would be wise to say any speed at a particular instant. I would note that it was found with the speedometer, and I sort of said this as it isn't in the reading, but I'm going to add it's the tangent to the curve when we're looking at a graph. Average speed. Let's see. Average speed in planning a trip by car, the driver often wants to know how long it will take to cover a certain distance. So the car will certainly not travel at the same speed the whole trip. The driver cares only about the average speed as a whole, and that is the total distance covered by the total time. So we like to use our delta. This is the change in distance over the change in time. Okay. So you're basically going to be taking an average speed calculated easily. So if we drove 60 kilometers during the time of 1 hour, your change in distance is going to be 60 and your change in times in 1 hour. What if we traveled 240 kilometers in 4 hours? Well, you'd take your total 240 over your 4 and you get 60 kilometers per hour. So note that then the distance in kilometers per hour is divided by hours. The answer is kilometers per hour. Okay. I prefer meters per second. I think that we're going to be using that a lot, so we might have to do some basic conversions. Just FYI, 1,000 meters equals 1 kilometer, and 3,600 seconds equals 1 hour. We'll do more of that when we do the equations and calculations for this. So when the distance, I said that, so since the average speed is the distance covered divided by the time travel, it doesn't indicate variations. This is kind of important to know. It doesn't indicate variations of speed that may take place during the trip. So in practice, we experience a variety of speeds on most trips. So the average speed is quite different from the instantaneous speed. So like I said, you look down at your speedometer, that's your instantaneous speed. But you know when you're on a trip, you speed up, you slow down, there's traffic, there's stoplights, stop signs. So when you talk about average or instantaneous speed, we're talking about a rate at which distance is traveled. So if we know average speed and travel time, the distance traveled is easy to find. So what they're saying here is you can find distance if you multiply speed by travel time. One of the things I showed you was this handy dandy little pyramid that your speed is your distance over your time. So with that, you could say speed is distance divided by time. You could look at distance and say, well, that's speed times time. And you could look at time and say, oh, well, that's easy. Time is distance divided by speed. So, for example, if your average speed is 80 kilometers per hour on a 4-hour trip, and you cover a total distance of 320 kilometers. So, it gives us a couple examples. I'd like to add this for you guys, and I think we did that in our notes too. But if you haven't, it'd be a good time to put them in. So I'd go over here and say average speed. It's the speed over your total distance and total time, okay? And it can vary. It's an average. I mean, you're going to put what you get out of that text as well. And then down here in the summary, let's make sure we're done reading the section. Okay. That hits on velocity 4.3. So that's in a different type of notes. So just in these couple of pages with speed, I would say good little summary. Let me go ahead and erase that line because it bothers me. There. And I'll use red. I'm going to go ahead and say the summary is, speed measures distance over time. I'd like to say that the units are meters per second. And I'd like to say instant versus average, and explain a little bit about how there's the speedometer and the total trip. Again, your notes don't have to be as nice as mine, but there's a quick example how you could have done the Cornell style notes. I hope this helps. Bye.